what is networking and communication. So few of questions from networking and communication we can answer after this session. Let's try to move forward. What is networking and communication? So computer network. So try to understand what is computer network. A network is nothing but multiple systems interconnecting between them. Multiple systems or multiple devices. But here we are talking about the computer network. A computer network is an interconnection of various systems which are located at different places. A computer A located at one place, computer B located at one place, and when we interconnected those two systems is nothing but a computer networking. In a computer network, two or more computers are linked together with a medium or data communication devices for purpose of communication and data sharing. Why to connect the different systems which are located at different locations? Just in order to share or communicate, in order to share the data or communicate among those systems. In order to communicate among those systems or in order to share data or information among the systems, we require that both systems or two or more systems to be connected. That is nothing but computer networking. The purpose of computer networking is to share data or to communicate among different systems. So that is exactly the purpose of networking or computer networking. The computer that provides resource to the other computer in a network is known as a server. When we are saying to share data or to communicate between two systems is to satisfy that purpose, so we are going for computer networking. So there are two types of resources. One will send the data, one will provide the service, other will consume the service. One will provide the service, other is consume the service. The computer that provides the resources, service is nothing but providing a resources. The computer which provides resources is known as server. The other end, the computer which accepts or which takes those resources is known as client or nodes. Okay. So here in this slide, we try to understand what is computer networking and why we need computer networking. And there are two systems. One is server. One is server. One is client. Server will provide the resources. Client will accept the resource or consume the resource. So typically there are two types of networking. One is local area networks, that is LAN. One is wide area network, that is WAN. The computers are geographically close together, is known as local area networks. When I say local area network, the computers are geographically close together. Is not that the systems are maybe within a building or maybe two different buildings. The systems which are located in a single building and connected in a network is called as local area network, or the systems which are in different buildings connected in a network is called as, again it is also called as local area network. The local area network, the name itself says it's a local, it's a limited space. The systems are connected in a limited space or in a multiple buildings, right? Wide area network, the name itself says it's a wide. It's nothing but the systems are very far from each other. It might be area, it might be in area level, or it might be in area level or in a geographical level. The computers are far apart and connected by telephone lines or radio waves. So when in a wide area network, the systems are very far from each other. Say suppose there are systems in Amirpet, okay, and few systems are in 𝗂𝗽𝗱, okay. To connect those systems, that kind of connection is known as wide area network. That kind of network is known as wide area network. These are connected by using telephone lines or radio waves. Okay, it may be wireless or it may be wired or wireless. Depends on the distance or depends on the region. So two types of network, LAN and WAN, based on the participation of the systems or based on the way the systems are connected. Again, that are further classified. That is called topology and protocols. Topology is nothing but the physical or logical network layout, the physical or logical network layout based on the systems connected in a network physically, or how the physically it got connected. Based on that, that is called as topology, that is named as topologies. Okay. Logical is nothing but the way in which the networks appears to be device that use it. Okay. Common topologies include bus topology, star topology, ring topology. Common topology is called bus topology, star topology, or ring topology. What is protocol? The protocol defines a common set of rules, signals that computer on a network use to communicate. One of the most popular topology for LAN is Ethernet. Another popular LAN protocol for PCs in IBM token ring network. Now the systems are connected in different areas in a network. To communicate between all those systems which are in a network, we have some set of rules. To communicate different systems in a network, we have some set of rules. These set of rules nothing but protocols. The protocol definition is the set of rules. So what we are using for this, to communicate systems in a network, right? So usually for LAN, the basic protocol is Ethernet. For LAN, the common protocol is Ethernet. Okay. So we understood what is topology, we understood what is protocols. Okay. Topology is nothing but the way systems are connected physically, logically in a network. So that names as a topology. So the basic topologies are bus topology, or ring topology, or star topology. Whereas protocol, to communicate among those systems which are connected in a network, there are some rules to follow. That is nothing but a protocols. So based on that also, the network is, the topologies are defined, or the network is defined. Okay. So few protocols are standardized. Architecture. Network can be broadcast classified as using either peer-to-peer or client-server architecture. Computer on a network are sometimes called nodes. Computer and devices that allocate resource for a network are called servers. Architecture says how the computers are connected. Is that peer-to-peer, or is that client-server architecture? Okay. Is that peer-to-peer or client-server architecture? Okay. Client-server architecture means there would be one centralized system which give the resources, and there might be multiple clients which consumes the resource. Like a boss and employees. There would be one boss who will provide the orders to their employees, or who gives the work to do for their employees, right? So here boss is nothing but server, and the clients is nothing but employees. Client will ask for the client will request the boss for any service, then boss will provide the service, or boss will provide the resource, right? Local area network, LAN, is a computer network that spans a relative small area. Most LANs are configured in a single building or group of buildings. However, LAN can be connected to other LANs over any direct via telephone lines or radio waves. A system LAN connected in a ways is called as a wide area network. Already discussed LAN, right? The systems which are connected in a small area. It might be in a single building, or it might be a group of buildings, right? It might be a single building, it might be a group of buildings. That is LAN. When these multiple LANs are connected in a network, now systems in a single building connected in a network is called LAN. When the multiple LANs connected in a network is called WAN, wide area network. So you can see this is how the LAN looks like. This is how the LAN local area network looks like. There are two servers and there are multiple systems. So it's nothing but it might be two different buildings are connected together. Okay. Most LANs connected workstations, personal computers. Okay. User can also use the LAN to communicate with each other by sending emails or engaging in a chat session. Okay. So LANs are capable of transferring data very fast, rather much faster than data. Right. Can we transfer over a telephone line, but the distance are limited? There is also a limit on the number of computers that can be attached to a single LAN. Okay. By using this LAN network, we can even send an emails. We can even send an emails within the systems which are connected in a LAN. We can share the information within the system we are connected in the LAN. As this is a limited area, as the area is very small, only limited systems can be connected. Only limited systems can be connected, and moreover, as the very small network or very limited computers are connected, so this by sending or receiving data would be very fast in a LAN network, because however the area is very small, the systems are connected, very small systems or very less number of systems are connected, then obviously sending and receiving the data, sending or receiving the information would be very fast. Coming to WAN, a WAN is a computer network that spans a relative large geographical area. Typically, a WAN consists of 2 or more LANs. Computer connect to a wide area network, that is WAN, are often connected to a public network such as telephone system. They can also be connected through leased line or satellites. The largest WAN existing in the internet. What is WAN? As I said, multiple LANs network connection is nothing but a WAN. Okay. So say suppose 10 LANs are there. We are connected those 10 LANs in a network. So that is called as a WAN. So how they connected? How they connected? It might be wireless, or it might be wired, or sometimes it might be satellite. Through satellite also we can communicate among those WANs. Right. So large WAN in an existence is the internet. So internet is the biggest WAN, I can say. So internet would be the biggest WAN. So this is how it looks like. This is how it looks like. So some different location. There are different location. California, New Jersey, some different Florida, some different location. The systems are connected to a common area or common server or common entity. So that is called as wide area network. Just you can imagine how wide it is. Okay, some different countries got connected to one point, right? So that is the WAN. As I said, network topologies. So the way systems are connected physically or logically, the way systems are connected physically or logically, so they are again classified. Okay, they are again classified. So one of them is star network. Okay, star network, or you can call it as star topology. Okay, star topology or star network. The star network is frequently used to connect one or more small computers or peripheral devices to a large host computer or CPU. Many organizations use the star network or a variable or a variations of it in a time sharing systems in which several users can able to share a central process. So how these star network are connected? Star network are connected one or more small systems, peripheral devices to a large computer or CPU, right? So the connection of the systems in a network would shape like a star, right? Would shape like a star. So it looks like a star structure. It look like a star structure, right? So that is why it is named as star network or star topology. Okay. So this is used in an organization, very time sharing system. So various of it in a time share system in which several users can able to share a central processor. So generally it is used in an organization, where in an organization there would be some central processor or central computer or main computer or main CPU where employees can share the data, or where employees can get the data or send the data to it. Okay. there would be one centralized CPU, or there would be a centralized processor where the employees in an organization would share or send a data. Okay, so that is nothing but a star topology or star network. All the computer devices connect to a central device called hub. Each device required a single cable. Point-to-point connection between the devices hub, mostly wide important hubs in a single point of failure. So how they are connected? So there is a device called hub through which the computers are connected in a network to a one. So there would be hub. So all the computers are connected to the hub, and the output, the other end of the hub would be connected to the one common CPU, common processor. So what is the problem in this? Mostly hub is single point failure. Okay. Say suppose 10 systems are connected to a hub. In a network, there are 10 systems which are connected through hub. Suppose there is a failure in hub. When I say failure, something went wrong with the hub. Then all these 10 systems would be collapsed. Okay, the network will be collapsed. So only single point of failure is hub. Okay, if the hub fails, then all the systems fails. The network collapse. So there won't be any communication. So that is major disadvantages in star topology. It's look like a star. Okay, the central part is a hub. Okay, the central part is a hub. To the central part of 5 systems are connected. Say suppose if there is a problem with this hub. Okay, if there is a problem with this hub, this is a hub. This is called as hub, and these are systems are connected. So what is the advantage of this? Okay, what is the advantage of this? Say suppose if there is any failure in this, then this system only goes out of network or out of communication. If there is a failure in this, only this system would be goes. Tomorrow I want to add few more systems to it. I can easily add. Okay. Tomorrow if I want to add few more systems, I can easily add, because there is a common location hub, and you can plug in one wire and you can add it. Okay, you can add it. But the major disadvantage is require more cables, right? So to see, for every single system there is an individual cable. So we require more cables. A central connection due to the device allows for a single point of failure. If this hub fails, then all the systems will not connect. All the systems will go out of network. More difficult to implement. So by this kind of topology is very difficult to implement. So these are the few advantages and disadvantages with respect to star topology. So one thing, star topology is used in a small organization where there would be one centralized location to which the systems are connected. To connect these systems, a device called hub is used. If there is a single point of failure, if hub fails, if there is any problem with the hub, then system will collapse, the network will collapse. The advantage is each individual system work individually. Okay, so if one single system fails, only the single system fails. It won't impact the network. Right. So adding and removing systems to a network is very easy. Because there would be a hub, centralized pointed device through which the systems can be connected. But one disadvantage is we need more wires, and if any failure in hub, the entire system will collapse, and it is very difficult to implement. So those are the advantages and disadvantages with respect to star network or star topology. Let's see other one. Ring topology. The ring network or ring topology is a local area network whose topology is a ring. Can be as simple as a circle or point-to-point connection of a computers at disappeared location with no central host computers or communication control. That is, all of the nodes are connected in a closed loop. Messages travel around the ring with each node reading those messages addressed to it. One of the advantages of ring network or ring topology is that can be span large distance than other type of networks such as bus network because each node registered message as they pass through it. Now ring topology or ring network. In a ring network, systems are connected in the form of a circle. In a ring network, systems are connected in a form of a circle. There won't be any master, or there won't be any client, or there won't be any centralized computer as like star topology, right? There won't be any centralized computer, or there won't be any server, okay, centralized area. But in this ring topology, it is a peer-to-peer connection or point-to-point connection. The physical structure would be like a ring. All the nodes are connected in a closed loop, nothing but a ring or a circle, a ring or a circle. Messages travel around the rings. Now, one system want to pass a message, so the network connection is like a ring, then obviously the message would travel as per the ring only, right? So, logical ring means that data travels in a circular fashion from one computer to the other computer network. Typically, FDDI, 𝗧-𝗦𝗔𝗧 or token ring topologies are used in implementation of a ring network. Ring networks are mostly common wide in a star configuration. Token rings has multiple station access unit equivalent to hub or switches. So, as I said, again the data travels in a circular fashion from computer to computer, as these are connected in a ring. So, the data travels in a circular fashion, which we already discussed, right? So, this is how it looks like. If you see here, computers are connected in a ring topology, in a ring topology or ring network. It's a circular fashion. Okay, it's a circular fashion. There is nothing called centralized. There is nothing central part to connect. So, it is connect to point to point. This is called as point to point connection. Point to point means one to one connection. This connected to this connected to this to this. So on. So, it form a ring, right? So, this type of connection is called point to point connection, and a point to point connection is in a form of ring. So, that is why we call it as ring topology or ring network. Few advantages are cable faults are easily located, making troubleshooting earlier. Okay. So, if there is any fault in a cable, that could be easily located, because say suppose if this breaks, then the communication between these two will be failed, right? The communication between these two will be failed. That can be easily located. Ring networks are modernly easy to install. So, these are very easy to install. If you want to add anything, you can add it. If you want to remove anything, you can remove it. So, what it says, if you want to expand this, okay, if you want to make it a bigger one, so definitely you need to break this, means you need to break the communication and we need to do. So, it means that the existing network will stop communicating, because when we want to add something to it. A single break in a cable can disrupt the entire network. If there is any single break, suppose if this system want to pass information to this system, if this system want to pass information to this system. However, if this breaks here, then the information will not go, right? So, if any single breaks, it collapse the network. If any single breaks, it collapse the network. So, that is one disadvantage of ring topology. So, in a ring topology, the systems are connected in a fashion of circular fashion or ring or in a closed loop, right? The message travels in a circular fashion. You can see. So, this is the structure of the ring topology. The one more is bus topology. Bus networks or bus topologies are similar to ring networks that are not connected. All the communication are carried on a common cable or bus and are available to each device on the network. Access and control of a bus networks are typically maintained by a method called contents whereby message at will be but two or more terminals initial messages simultaneously. They must stop and transmit against at different intervals, right. So, how this bus in a bus network or in a bus topology, how the systems are connected. So, in a bus topology and bus network, systems are connected to a common cable. There is one cable which is common, and to that common cable, the systems are connected either side of the cable. All the communication are carried to a one common cable or bus and available to each device on the network. Right? There would be a common cable, and to the common cable, all the systems are connected and would be communicating through that cable only. Use a trunk or backbone to which all of the computers on the network connect. System connect to this backbone using T connector or tapes. Coaxial cables were popular option years ago. So initially it was coaxial cables. To implement this bus topology, they use coaxial cables to connect the systems. So there would be one backbone to which all the computers are connected. Okay, let's see how it looks. So this is how it looks. So here you can see this is a common cable. To this common cable, all the systems are connected. To this common cable, this is a common cable, and this system is connected, so on, right. So what is that? Let's see the advantages of this. Cheap and easy to implement, because there is no complex, it's straightforward, right. A single cable, and since multiple systems are connected to that single cable. So there is no complex, easy to implement. Requires less cable. As to a single system, multiple systems are connected, so cables required is very less. Does not easily any specialized network equipment. Does not use any specialized equipment. So there is nothing nothing called hub, nothing switches, nothing is there. No other devices are used. Just simple a cable network. What is the disadvantage of this? Network disruptions when computers are added or removed. Okay, so if you want to add a computer, or if you want to add or if you want to remove the computer, the network will be disruption. The network will be disturbed. A break in the cable will provide all the systems from access the network. Difficult to troubleshoot. Suppose if there is a break in this cable, in the common cable, this is a common cable, right? If this is a common cable, if something went wrong with this cable, or if there is a break with this cable, then entire system will collapse. Suppose if there is a break here, there is no communication between those two systems, or no communication between among these two systems. Difficult to troubleshoot because it is connected to a single network. We don't know if there is any break. We need to check everything. We need to check this system, So every system we need to check, because one break cause error to any of the system, any among these system. One break cause any of the systems among these, right? So it's difficult to troubleshoot. Okay, so if there is an issue in the bus network or bus topology, it's difficult to figure out. Okay, it's difficult to figure out, right? So, but easy to implement, very cheaper, and a common cable connected with a multiple pieces. But though it is having these many advantages, but the common and disadvantage is difficult to find the failure of the network or if any issue with the common cable, then entire network will collapse. Okay, that is a major disadvantage of bus topology. Let's see the next one, mesh topology. Each computer connects to every other. High level of redundancy, rarely used. Wiring is very complicated. Cable cost is high. Troubleshooting failed cable is tricky. A variable hybrid mesh creates point-to-point connection between specific network device, often sees in a WAN implementation. Each computer connected to each other. High level of redundancy, rarely used. So this mesh topology is very rarely used. So every computer connected to each other. If there are 10 computers in a network, so 10 computers connected to each other. So computer 1 connects with all 9 computers. Computer 2 connects with all other 9 computers. Okay, so every computer is connected to each other again. Is connected to each other. High level of redundancy. So it's like a very tricky. The connection itself looks like very tricky. You really it's very difficult to figure out the fault. If any issue in the network, it is hardly to figure out the fault. So because of that it is not rarely used. Because of these all reasons, it is not rarely used. It is used rarely actually. It's not regularly used. So how these connected? Even if the communication between those systems are even not necessary, still it is getting connected. I mean to say, if there are 5 systems, so 5 systems should connect among themselves. System 1 connects with 2, 3, 4, 5. Again system 2 connects with 1, 3, 2, 4, 5. So on. Right. So just imagine if the network increases, then complexity of the network would be increased. If you go and add the computers to the system, then complexity of the network will be increased. Say suppose if there are 5 systems, you want to connect one more system. If you want to connect sixth system, then you need to connect to all those 5 systems. Right. So that is the complexity with this mesh topology. Right. Let's see how it looks. If you see here, this is a mesh topology. System 1, system 2, system 3, 4. 4 systems are there. See, 4 systems. Again, system 1 is connected to this one. This system is connected to this system. Again, this system and other 3 systems. Right. If you see here, this system is connected to here. It connected to here. It connected to here. Means in the network, all the systems are connected to each other. Now say there are 4 systems. If you want to add one more system here, then you need to connect to this system, this system, this system, this system. Right? All 4 connections you need to make, even if you add one system here. Right? However, it is easy to connect, but still, when systems goes and increases, when the network getting increase, the complexity will increases. When complexity increases, obviously the troubleshoot will be difficult. What is the troubleshoot? Nothing but identifying a faults in a network would be difficult. Let's see the advantages. Providing redundant path between devices. So all the devices has path to every device. The network can be expandable without disturbing to the current users. So if you want to expand, if you want to add one more system, you can add it, you can connect it. So you no need to break this network. You no need to break this existing network. However, you can add one more system here and connect to the existing network. That is one advantage. Require more cables than the other LAN topologies. Yes, definitely. If you add one system, then you need to connect this one, this one, this one, this one. All 4 systems you need to connect. For that, obviously, you need more cables to connect. Complicated implementation. Yes, definitely. When you goes on add network, the connections are increasing. So one computer you are connecting 4 systems, right? Connection is getting increased. The complexity is getting more complex, right? More complicated, more complex, and troubleshoot. If there is an issue with the system, then it is very, very difficult to figure out. If there is an issue with the system, then it is very, very difficult to figure out. This type of network is rarely used because it might be having few advantages, but the disadvantages are high here. Okay. So when complexity increases, connectivity increases, when all this getting increases, then definitely the maintenance would be very high, right? Because for one connection, you need to check all other connections, right? So maintenance would be very huge or very high. Okay. So this is a major disadvantage of mesh topology. So far we saw all wired networks, right? All wired networks, all cables, connection, all such type of stuff. So in a network, again, the systems can be connected wireless or wired. Okay. The network is network. How they are connected? It might be using cables, or it might be waves, radio waves, right? Wireless, right? Or satellite. So let's see wireless network. Does not require physical cables. Okay, does not require physical cables, but particularly useful for remote access for laptop users. Eliminate cables fault and cable breaks. Signal interface or security issues. Okay, there is no physical cables are required for this network. So usually these networks are used to access some remote something from remote location. Okay, usually these systems are used to access some remote location. Okay, so how these satellites are working is working on a wireless basis. There is no wire connected to the satellite, right? It's sending the signals or sending the information through wireless only, right? That is one of the example. That is also WAN network. Eliminate cable fault. When there is no cables, then there is no issue with the cable faults or failures or something, right? If there is no wire, then obviously there won't be point issue in cables or faults, right? So there won't be any faults in the cables. Okay. Signal interface. Definitely. If there is no wires, then the data would be communicating through signals. There would be many security issues, right? Because it's a wireless, there might be many security issues because of we are accessing some remote location systems through signals. So it might be somewhere it may break, right? So that is what wireless networks. The laptops here, of course there is one system here and 2 laptops. There is nothing cable, there is nothing physical link here, right? There is no physical link. However, there is some device over here which accepts the signals, and it connect backend. It's connecting to some other systems. Okay, it is connected to some other system. So this is this is a not wireless network, and front part is a wireless network, right? So it passes the signals here, and it passes the signals to this, and similarly it will connecting to these systems. Let's see what is the advantages. Allows for wireless remote access. Okay, so there is no wire, so we can access if you are going for wireless remote access, then that is nothing but a wireless network. Network can be expandable without disturbing to current users. So yes, definitely you can expand the network, because there is no need connection, there is no need wire, right? So if you add one more system here, so there is no disturbance to this existing one. Potential security issues associated with the wireless transmission. There might be some security issues because this is a wireless network, so data will flow with the help of signals. So there might be security issues. That is one disadvantage. Limited spread in a comparison to other network topologies. Limited spread. There are very less spreading in this one network topology in a wireless. So wireless network. In a wireless network, the systems are connected without using any physical cables. So major advantage is there is no cable faults. There is no cable faults because we are not using any cables, right? And one more advantage is we can go and add n number of systems or n number of systems without disturbing the existing networks, right? So that is one major advantage. The very major disadvantage is the security issues. There might be lot of security issues. Okay, we need to choose appropriate appropriate communication channel, right? So there might be the huge security issue. That is one wireless network. So to communicate between all the systems, so there is a set of rules, network topologies. Network topology is nothing but rules in a network. Okay, rules to a systems that are connected in a network, right? A topology is an agreed upon format for transmitting data between two devices. The topology determines the following. A topology is an agreed upon format for transmitting data between two devices. The protocol determines the following. The protocol determines the following. The type of error checking to be used, data compression method if any, how the sending device will indicate that it has a finished sending a message, how the receiving device will indicate that it has a received a message. There are various of standards protocols from which program can be choose. Each has its own particular advantages and disadvantages. For example, some are similar than the other. Some are more reliable and some are faster. One system sends the information to other system. There should be acknowledgement thrown back to the sender stating message is sent. Similarly, one system receives the message. One system receives the message from other system, then there should be acknowledgements. There should be acknowledgement sent back stating receive the message. Receive the message. There are various standards protocols for which the programs can choose protocols or list of rules. There are various set of rules based on the communication, based on the network, based on the interface, based on the medium they are communicating. Okay, so for wireless there might be some protocols. For wired there are for wired or cable there are some protocols. Okay, based on the network, based on the media they are communicating, the list of topologies can be selected. Okay, so nothing but the protocols. Protocol is nothing but a list of rules, a standard rules. Okay, the systems in network has to follow those rules. The systems in a network has to follow those rules. That's it. That is network protocols. The protocol can be implemented either in hardware or software. Some of the popular protocols are TCP/IP, HTTP, FTP, SMTP, POP, token ring, Ethernet, X-modem, Kermit, MNP, etc. The protocols can be implemented either in a hardware or a software. The protocol nothing but a set of rules that can be implemented in a hardware or that can be implemented in a software. Okay, no specific area for these protocols. Protocols can be implemented in both hardware or software. Some of the popular protocols are called TCP, IP, HTTP, FTP, POP, MOM, or some of the few popular protocols. Okay, or these popular protocols. So based on the network or what you are using, the protocols will be followed. Network architecture. So network protocols are set of rules. Then what is network architecture? The term architecture can refer to either hardware or software, or a combination of hardware or software. The architecture of a system defines its board outline and may defines precious mechanism as well. The term architecture can refer to either hardware or software or connection of a hardware or software. The architecture of a system always defines its board outlines and may defines piece mechanism as well. In a protocol, in a network protocol, it's common, can be implemented in hardware and software. Right? But here the term architecture refers to hardware or software and connected and combination of hardware and software. Architecture of system always defines a broad line. So outline, so basically how the systems are connected. Architecture is nothing but the outlines of a particular system, particular hardware components or software. Even in software, we can implement, or this can be referred as an architecture can be referred. Right? In a hardware, it is a physical. In a software, it is a logical. In a hardware, that architecture would be the physical, in a physical representation. In a software, the architecture would be a logical representation. Similar, so when we talking about the architecture, again we have something called as peer-to-peer architecture. Peer-to-peer architecture. This type of network is which each workstation has equivalent capability and responsibilities. The difference from client-server architecture, in which some workstations are decided, the server and the other. Peer-to-peer networks are generally similar and less expensive, but they usually do not offer same performance under heavy load. So what is this peer-to-peer architecture? In a peer-to-peer architecture, all the systems connected in a network are commonly capable of. Okay, all the systems or systems in a connector in a network are commonly capable of. Right, or commonly capable of. Say suppose system 1 and system 2, there are two systems in a peer-to-peer architecture. So what is the importance of system 1 is the same importance of system 2 is also. What is the capability of system 1 is the same capability of system 2 is also. Right. So there is no master, there is no server. Right. In this both, there is no master. Okay. Both are on same page, both are on same importance, both are on same capability. Such network or such architecture are called peer-to-peer architecture. Okay. Such architecture are called peer-to-peer architecture. Generally similar as less expensive. Okay. In a peer-to-peer architecture is very similar and is very less expensive. Similar in sense nothing but two different systems having same capability or same capacity or same same importance, right, and less expensive because these don't have high duties, they no need to maintain, right. So that's why it's very similar or very less expensive. Client server architecture, in peer-to-peer architecture, one system, two different systems has equal importance, but in client server architecture, there would be one system which is a master, there would be the multiple systems, there would be many systems which is connected to that master, that is clients. Okay. Server will provide the resource, client will consume the resource. Okay. Server will provide the resource, client will consume the resource. Okay. The system which provide the resource is called as server. The systems which consume the resource, the system will accept the resource, are called as clients. Okay. System that accepts the resource are called as clients. Okay. So there would be one boss and multiple clients. Okay. So if client 1 requires any information, it asks for the boss. Okay. So this is all about the networking and communication. So we learn what is networking, we learn types of networking. Okay. We learn protocols, we learn client architecture. What is the purpose of networking we understood in this session. Thank you.